Hello viewers, welcome to my channel. Today I'll be solving this wonderful Olympiad exponential equation. Now my first step now will be to take the ln of both sides in this equation. So right, you see ln 3x is equal to ln open bracket 3 root x plus 1 all raised to the power of x raised to the power of 3 root x plus 1 minus 3x. Now my next step now will be to write this ln 3x again. So write ln 3x equal to, now I'm going to take the power here now behind according to the law of logarithm. So we write this now as what? X raised to the power of 3 root x plus 1 minus 3x. Then ln 3 root x plus 1. Then now this ln 3x, I'm going to write it as 1 times ln 3x all equal to x raised to the power of 3 root x plus 1 minus 3x, then ln 3 root x plus 1. Now my next step now will be to compare both sides of this equation. Now I will say that this one is equals to this x raised to the power of 3 root x plus 1 minus 3x. So we write 1 equal to x raised to the power of 3 root x plus 1 minus 3x, and also this ln 3x is also equal to ln open bracket 3 root x plus 1. So I compare both sides. This one here is equal to this, and this ln 3x is also equal to ln this. Then my next step now will be to write this x as this one as x raised to the power of 0. So this one can be written as x raised to the power of 0 equal to x raised to the power of 3 root x plus 1 minus 3x. And now I'm going to make this ln 3x as a power to e, and we all know that e stands for the Euler number. So we write this as e raised to the power of ln 3x. So I'll do the same for the right hand side of this equation. So we say e again raised to the power of ln bracket 3 root x plus 1. Then now, since in this expression here now, since the base is equal, I'm going to equate the power. So write 0 equal to 3 root x plus 1 minus 3x. And here now, we have e raised to the power of ln 3x. So this is same thing as what? 3x equal to, why this is same thing as 3 root x plus 1. So we continue. Now I'm going to rearrange both equations. So now on rearranging this, I got 3x minus 3 root x minus 1 equal to 0. Then this and I'll put my and. Then also I'm going to rearrange this, so we have 3x minus 3 root x minus 1 all equal to 0. As you can see now, the two equations are the same. So I will just write one of them and use it to get the root of this equation. So write 3x minus 3 root x minus 1 equal to 0. So this is the equation I'll be solving now. Now, I'm going to write this x as the square root of x squared. So here will become 3 bracket the square root of x squared minus 3 root x minus 1 all equal to 0. So this equation here now is the same thing as this, and if you look at this very well, it is a quadratic equation. So my next step will be to say that let root x, the square root of x, be equal to k. So then we'll continue. Anywhere I see the square root of x, I put k here. Put k, I replace it with k. So here will now become 3k squared minus this 3 again, k minus 1 all equal to 0. So this is a quadratic equation, and I'm going to solve this quadratic equation using the formula method. Now, in this quadratic equation, my a is equal to 3, my b is equal to minus 3, my c is equal to minus 1. Then from here now, I can write my quadratic formula. My quadratic formula is k equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is my quadratic formula. Then now we'll continue again. This k, I'll write it again. K equal to minus, now b is minus 3, so open a bracket and put minus 3 there, plus or minus the square root. Now b squared, so we say minus 3 squared minus 4 times a is 3, a is 3 times c is minus 1, everything all over 2a. That means 2a, that's 2a is 3, so we say 2 times 3, that's all 6. Then we continue again. K will be equal to minus times minus is plus, so here will become 3 plus or minus. Now I'm going to simplify everything. I'll find the square root of minus 3 squared minus 4 times 3 times minus 1. On doing that, I got this expression here as the square root of 21 all over 6. So from this expression here now, I can say that k is equal to 3 plus the square root of 21 all over 6, or k equal to 3 minus the square root of 21 all over 6. Then we continue again. I'll say recall the square root of x is equal to k. So anywhere I see k, I'll replace it with what? The square root of x. So right, this is k, so here will become the square root of x equal to 3 plus the square root of 21 all over 6, or this is k, and k is same thing as the square root of x. So here will become the square root of x equal to 3 minus the square root of 21 all over 6. So my next step now will be to square both sides of this equation. So I'm going to square this one now. To remove the square root sign, we have to square both sides. So here will be square of this side, and also I'll square this side also again. Then I'll square this. And also I'm going to square this side also. Now square will divide square root sign, so we have x equal to, then now I'm going to open this, expand this, so here will become 9 plus 6, 9 plus 6 root 21 plus 21 all over 6 square is same thing as 36, or square both side here again. Now square will divide square root, so we have x equal to 9 minus 6 root 21 plus 21 all over 36. Then we continue again. We continue. Now we say x equal to, now 9 plus 21 will give me 30 plus 6 root 21 all over 36, or x equal to 9 plus 21 will give me 30 also again, so we say 30 minus 6 root 21 all over 36. Then now I'm going to factorize this, so we say x is equal to 6 open bracket, here will become 5 because 30 divided by 6 is 5, then plus just root 21 all over 36, or x equal to, factorize again, 6 open bracket, 30 divided by 6, that's 5, minus square root of 21 all over 36. Now 6 will divide 36, so we have x equal to 5 plus the square root of 21 all over 6, because 6 divided by 6 once, 36 divided by 6 is 6, so that's how we get the 6 here. Or you can say x equal to 5 minus the square root of 21 all over 6 also. 6 divided by 6 1, 36 divided by 6 6. So now this is my final solution, but the only acceptable root for this our equation is this, which is this one. So this is the only acceptable root for my equation. So thanks for watching. Please subscribe to my YouTube channel for more interesting videos.